So in fourth module, that means partial differential equations, we have a formation of partial differential equations by eliminating arbitrary constants or arbitrary functions. If a given relation is of the form f of x, y, z, b equal to 0, where z is a function of x and y and a and b are arbitrary constants, to form a partial differential equation, we have to differentiate the function with respect to x and y partially, and also we have to eliminate the arbitrary constants. If in case the number of arbitrary constants are more than the number of independent variables, then we need appropriate number of partial derivatives of second and higher order also. The following standard notations when z is a function of two independent variables x and y are to be used. We take p, small p equal to del z by del x. If we differentiate partially the given function z with respect to x, we take that as p, small p or zx. And also del z by del y, that means differentiation of z, partial differentiation of z with respect to y is taken as small q or zy, and double differentiation of z with respect to x is taken as r equal to zxx, and double differentiation of z with respect to y is taken as t, small t or zyy. And here we have s equal to del square z by del x into del y. That means we are going to differentiate del z by del y again with respect to x. That is also taken as zxy. Now we have problems. Find the PDE by eliminating the arbitrary constants. In the equation z equal to x plus a into y plus b. So first we are going to differentiate the given equation partially with respect to x and with respect to y. So take the given equation as 1. Now differentiate with respect to x and y partially. So we take p equal to del z by del x. That means differentiation of z with respect to x. So if we differentiate the given equation with respect to x partially, so y plus b becomes constant, but it is attached to x plus a. Therefore, here differentiation of x is 1 and a equal to 0. That means 1 plus 0 is 1 into y plus b. That means p becomes y plus b. Similarly, if we differentiate z with respect to y, then x plus a becomes constant, and differentiation of y with respect to y is 1 plus differentiation of b becomes 0. So 1 plus 0 is 1. So 1 into x plus a becomes x plus a. Therefore q becomes x plus a. Now substitute these values in equation 1. So z becomes x plus a is q and y plus b is p. Therefore z is equal to pq. So that is the partial differential equation, required partial differential equation. Now second equation is 2z is equal to x square by a square plus y square by b square. So take the given equation as equation 1, differentiate the given equation with respect to x and y partial. So with respect to x, we will take that as p. So first with respect to x, 2z becomes 2 into del z by del x, which is equal to differentiation of x square by a square with respect to x is 2x by a square plus y square by b square is constant, therefore that becomes 0. So here we take del z by del x as p. So that is 2p is equal to 2x by a square. Left side 2 and we have a right side also 2, that those will get cancelled. So finally we get a square is equal to x by p. And now we differentiate the given equation with respect to y partial. So 2 into del z by del y is equal to, here x square by a square is constant, so that will become 0, plus differentiation of y square by b square with respect to y is 2y divided by b square. Again here 2 and 2 get cancelled, we have b square is equal to y by q. Now substitute the values a square and b square in the given equation 1. We get 2z is equal to x square by x by p plus y square by y by q. So solving this, we obtain 2z is equal to px plus qy, which is the required PDE. Next we have z is equal to a log of x square plus y square plus b. So take the given equation as equation 1 and differentiate equation 1 partially with respect to x and y. So z del z by del x, that means p is equal to, here a is a constant, so a into differentiation of log of x square plus y square with respect to x partially becomes 1 divided by x square plus y square, and again differentiation of x square is 2x plus differentiation of y square is 0, since y square is a constant when we are going to differentiate with respect to x partially, plus differentiation of b is a constant, therefore that is also 0. So finally we have p is equal to 2ax divided by x square plus y square. Now differentiate z with respect to y, so that is del z by del y, which is equal to q, equal to, again a is a constant, so a divided by differentiation of log of x square plus y square with respect to y is 1 divided by x square plus y square into differentiation of x square with respect to y is 0 plus differentiation of y square with respect to y is 2y, plus again differentiation of b with respect to y is 0. So finally we have q is equal to 2ay divided by x square plus y square. So substitute the values in equation 1, or we may also take p by q. So divide equation 2 by equation 3, that will become p by q is equal to 2x by x square plus y square into value of q, that will be in reverse condition, that means x square by y square divided by 2ay. So here 2a get cancelled and x square plus y square also get cancelled. We have p by q is equal to x by y, or py minus qx equal to 0 is the required PD. Next problem, z equal to xy plus y of square root x square minus a square plus b. Now take the given equation as equation 1 and differentiate with respect to x and y partially. So if we differentiate with respect to x, that means del z by del x, which is equal to p, equal to differentiation of xy with respect to x is y, since x becomes 1, plus y into square root of x square minus y a square, differentiation of square root of x square minus a square with respect to x becomes 1 divided by 2 into square root of x square minus a square. Again differentiation of x square with respect to x is 2x minus differentiation of a square is 0 plus differentiation of b is also 0. So finally we obtain p is equal to y plus, here 2 and 2 get cancelled, so y plus xy divided by square root of x square minus a square. Now with respect to y, that is del z by del y, which is equal to q equal to, so with respect to y, differentiation of xy becomes x since y becomes 1 plus differentiation of y into square root of x square minus y square. Here also y becomes 1 and hence we have square root of x square minus a square, and differentiation of b is 0 since b is constant. Now from equation 3 we have q minus x equal to square root of x square minus a square. Here in equation 3 we shift x to left side, so that will become q minus x equal to square root of x square minus a square. So using this in equation 2 we obtain p is equal to y plus xy divided by square root of x square minus a square, means q minus x from equation 3. So if we take y to left side, we obtain p minus y is equal to xy divided by q minus x, and cross multiply we get p minus y into q minus x equal to xy. So if we solve this, we obtain pq equal to px plus yq, which is the required partial differential equation. Next we have to construct a partial differential equation by eliminating arbitrary functions. Previously we formed the partial differential equation by eliminating the arbitrary constants, where the arbitrary constants are a and b. Here we are going to eliminate arbitrary functions. So first equation is z equal to y square plus 2 f of 1 by x plus log y. Here f of 1 by x plus log y is a arbitrary function. So take the given equation as equation 1. This is also same procedure. So first we have to differentiate the given equation with respect to x and y partially. So then del z by del x becomes p. We take del z by del x as small p, which is equal to, so differentiation of y square with respect to x is 0 plus 2 into differentiation of the function, that means f dash of 1 by x plus log y. Now we differentiate the terms which are in the function, that means differentiation of 1 by x with respect to x is minus 1 by x square plus log y. Since we are going to differentiate with respect to x, log y is constant and hence that will be 0. So finally here minus 1 by x square becomes px square when it comes to left side. So px square equal to minus into 2f dash of 1 by x plus log y. Take that as equation 2. Now differentiate with respect to y partially. That means del z by del y, which is equal to q, which is equal to, so here y square, differentiation of y square with respect to y is 2y plus again differentiate the function. So 2 into f dash of 1 by x plus log y. Now differentiate the terms which are in the function with respect to y. So 1 by x becomes 0 with respect to y plus log y, differentiation of log y with respect to y is 1 by y. So cross multiply y to left side, we obtain qy equal to 2y square plus 2f dash of 1 by x plus log y. Take 2y square to left side. So qy minus 2y square equal to 2f dash of 1 by x plus log y. Here y is a common factor, so that will become q minus 2y of y equal to 2f dash of 1 by x plus log y. So that is equation 3. Now divide equation 2 by equation 3. We obtain px square divided by q minus 2y of y, which is equal to minus 2f dash of 1 by x plus log y divided by 2f dash of 1 by x plus log y. So here 2f dash of 1 by x plus log y get cancelled from numerator and denominator. We obtain only minus 1. So we have px square is equal to minus qy plus 2y square by cross multiplying q minus 2y of y to right side. Thus px square plus qy equal to 2y square is the required PDE. So in the given equation we eliminated the function, that is f of 1 by x plus log y, to obtain the required partial differential equation. So in this form we have to eliminate the arbitrary function. Now we have to solve the next problem, that is z is equal to e power ax plus by tf of ax minus by. So here the arbitrary function is f of ax minus by. We have to eliminate that function. So take the given equation as equation 1 and differentiate the equation with respect to x and y partially. So first with respect to x, that is del z by del x, which is taken as small p, which is equal to, here we have product of two functions. E power ax plus by is one function and f of ax minus by is another function. So use the product rule. So e power ax plus by is the first function, keep it as it is. So differentiation of f of ax minus by is f dash of ax minus by. Again differentiation of ax minus by with respect to x. So differentiation of ax is a, since x becomes 1, minus differentiation of by with respect to x is 0, plus now keep second function f of ax minus by as it is and differentiate the first function e power ax plus by. So differentiation of e power ax plus by is e power ax plus by, and differentiation of ax plus by is a, since x become 1 and by is a constant. So finally p is equal to e power ax plus by the f dash of ax minus by into a plus, so this is a into z, since e power ax plus by into f of ax minus by is z, we take that as az. Take this is equation 2. Now with respect to y, that is del z by del y, which is taken as q equal to, so here also we are going to use the product rule. So first function e power x plus by into differentiation of second function, that is f dash of ax minus by, and differentiation of ax minus by with respect to y. So here ax is constant, that will become 0, minus by. So here y becomes 1, so minus b into 1 is minus b, plus again differentiation of first function, that means e power ax plus by becomes e power x plus by into differentiation of ax plus by. Here ax becomes 0 plus b into y, differentiation of y is 1, so b into 1 is b, and second function, so keep it as it is, f of ax minus by. So q is equal to minus b into e power ax plus by f dash of ax minus by plus b into z. So take that as equation 3. Now multiply equation 2 by b and equation 3 by a to make it as similar. So BP is equal to AB to e power ax plus by f dash of ax minus by plus abz, that is equation 4, and multiply equation 3 with a. That means aq is equal to minus ab to e power ax plus by f dash of ax minus by plus abz. So now adding equation 4 and 5, we obtain first left side, that is BP plus AQ, which is equal to, here first terms, that is AB e power x plus by f dash of ax minus by, and minus AB e power x plus by f dash of ax minus by get cancelled. Remaining is abz plus abz, that is 2bz, 2abz. So BP plus AQ is equal to 2ABZ, which is the required PDE. Next one, LX plus MY plus NZ equal to pi of x square plus y square plus z square. So take the given equation as equation 1 and differentiate with respect to x and y partial. So with respect to x, so here Lx, differentiation of Lx is L, since x becomes 1. Differentiation of My plus Nz becomes 0 with respect to x, equal to function pi of x square plus y square plus z square. Its differentiation is pi dash of x square plus y square plus z square, and differentiation of x square is 2x plus differentiation of y square is 0 and z square. Since z is a function of x and y, we have to differentiate the function z with respect to x. That will become 2z into del z by del x. So we get L plus n into p, del z by del x is p, equal to pi dash of x square plus y square plus z square, 2x plus 2z p, since del z by del x is p. Take it as equation 2. Now differentiate with respect to y. So Lx becomes 0. Differentiation of My is m, since y becomes 1, and m into z. Differentiation of z is del z by del y with respect to y, which is equal to pi dash of x square plus y square plus z square into differentiation of x square is 0 plus differentiation of y square is 2y plus again differentiation of z with respect to y is 2z square, 2z into del z by del y. So we obtained m plus n into q, which is equal to pi dash of x square plus y square plus z square of 2y plus 2zq, which is equation 3. Now divide equation 2 by 3. We obtain from left side L plus NQ divided by M plus NQ, L plus NP divided by M plus NQ, which is equal to, here the arbitrary function pi dash of x square plus y square plus z square get cancelled. Remaining is, in equation 2 we have 2x plus 2zp. In equation 3 we have 2y plus 2zq. Taking 2 outside and cancelling that, we get x plus zp divided by y plus zq. Cross multiplying the equations, we get x plus zp into m plus nq, which is equal to y plus zq into l plus np. So multiplying these terms, we obtain mx plus xnq plus mzp plus nzpq, which is equal to ly plus lzq plus mpy plus lzq. Next we have a note, that is to form a partial differential equation from q of uv, which is equal to 0, where u and v are functions of x, y, z. Here z is also a function of x and y, and also u and v are also functions of x, y, z. So we have to follow the following procedure. So first, the given equation q of u comma v equal to 0 is taken as equation 1. Now differentiate the given equation with respect to x and y partially by applying chain rule. So chain rule we have already discussed in first semester. So that is given as, so first we need to differentiate the given function with respect to x partially. So here differentiation of pi with respect to u, that is del pi by del u. Again differentiation of u with respect to x, that is del u by del x, plus differentiation of function with respect to x again. So here we split the function as u and v. So that becomes del pi by del u into del u by del x plus del pi by del v into del v by del x, which is equal to 0. Now with respect to y, that will become del pi by del u into del u by del y plus del pi by del v to del v by del y, which is equal to 0. Next, transform the second term in both equations 2 and 3 onto the RHS and divide. We obtain the required PD. So we have a problem pi of xyz comma x square plus y square minus z square equal to 0. Here x plus y plus z is one function. We will take that as a u, and x square plus y square minus z square is another function. We take that as v. So finally we get pi of uv equal to 0. So take that is equation 1. Now we have u is equal to x square, x plus y plus z, and v equal to x square plus y square plus z square. Differentiate each u and v with respect to x and y partially. So del u by del x becomes differentiation of x is 1, y is also 0, and z is a function of x and y, and hence that will become del z by del x. So that is equal to 1 plus p. Now v with respect to x, del v by del x is equal to differentiation of x square is 2x plus differentiation of y square is 0 minus differentiation of z square with respect to x is minus 2z into del z by del x. So which will become 2 of x minus zp. Now with respect to y, so u with respect to y is del u by del y, which is equal to, with respect to y, differentiation of x is 0 plus y becomes 1 plus z is a function of x and y, and hence with respect to y that will become del z by del y. So which will be 1 plus q. Now v with respect to y, del z by del y, which is equal to x square becomes 0, and differentiation of y square is 2y minus differentiation of z square with respect to y is 2z into del z by del y, which can be written as 2 of y minus z cube. Now differentiate equation 1 with respect to x and y partially by applying chain rule. So the standard equation chain rule equation is del pi by del u into del u by del x plus del pi by del y into del v by del x equal to 0, which can be written as del pi by del u into del u by del x, which is equal to minus, by taking the second term to right side, we get minus del pi by del v into del v by del x. Take equation 2. and with respect to y, that means del pi by del u by del y plus del pi by del v into del v by del y equal to 0. Take the second term to right side, we get del pi by del u to del v by del y minus equal to minus del pi by del v into del v by del y. Take it as equation 3. Now divide equation 2 and 3, we get del u by del x into del u by del y equal to del v by del x divided by del v by del y. So this is a standard equation. We use this equation in all the problems. Del u by del x by del u by del y equal to del v by del x divided by del v by del y. So from the problem we have del u by del x, del v by del x, del u by del y, del v by del y. So substitute all these values in the standard equation. We obtain 1 plus p divided by 1 plus q, which is equal to 2 of x minus zp divided by 2 of y minus zq. By cross multiplying and solving this, we obtain p of y plus z minus q of z plus x equal to x minus y, which is the required partial differential equation. So next we have f of x square plus 2yz y square plus 2xz equal to 0. Here we take x square plus 2yz equal to u and y square plus 2xz equal to v. Then the given function becomes f of u comma v equal to 0. So take that as equation 1. Now differentiate u and v with respect to x and y partially. So first with respect to x, we obtain del u by del x is equal to differentiation of x square with respect to x is 2x plus 2y into differentiation of z with respect to x is del z by del x. So we have del u by del x is equal to 2x plus 2y into p, since del z by del x is p. Now differentiate v with respect to x. So del v by del x is equal to differentiation of y square is 0 with respect to x, and 2x into differentiation of here we use product rule to differentiate 2xz. So keep 2 outside, so differentiation of x is 1, so z is second function, keep it outside, plus keep first function x as it is, and differentiation of z is del z by del x. So finally del v by del x is equal to 2 of z plus xp. Now differentiation of u with respect to y, that is del u by del y, which is equal to, again here also we are going to use product rule. So x square becomes 0, so plus 2, keep 2 outside, so first function difference y and second function is z. Differentiation of first function y is 1 into z plus keep first function y as it is, and differentiation of z with respect to y is del z by del y. So del u by del y is equal to 2 of z plus y cube. Now differentiate v with respect to y. Del v by del y is equal to differentiation of y square is 2y plus 2 into x into differentiation of z is del z by del y. So del v by del y is equal to 2 of y plus x cube. So we have a standard result, del u by del x divided by del u by del y, which is equal to del v by del x plus del v by del y. So substitute the values. We obtain 2 of x plus yp divided by 2 of z plus y cube, which is equal to 2 of z plus xp divided by 2 of y plus x cube. So solving this, we obtain x plus yp to y plus x cube, which is equal to z plus xp into z plus y cube. Multiply each terms, and finally we obtain y square minus 2z of p plus x square minus zy of q equal to z square minus xy. So that is the required partial differential equation. One more thing, I have shared material regarding one dimensional heat and wave equations. So try to practice it. If you got any doubts, please call me at any time.